associated with the systems in your plant. Although diagrams vary depending on the kind of systems they represent, there are some aspects of reading them that apply to practically any diagram. In this unit, you'll see how to read piping and instrumentation diagrams and interpret instrument symbols used on them. You'll see how to use a system diagram to locate equipment in the plant, and you'll learn how to interpret some common symbols found on electrical diagrams. Topic 1. Piping. Topic 1. Piping and instrumentation diagrams. In this topic you will learn to identify instruments using an identification chart. Identify line symbols and instrument symbols used in piping and instrumentation diagrams. Topic 2. Using a system diagram. In this topic you will learn to describe the types of information typically found in a legend. Locate the components in a boiler fuel oil system by identifying the symbols used to represent them. Topic 3. Electrical diagrams. In this topic you will learn to identify symbols commonly found in one-line electrical diagrams. Trace out a typical one-line diagram and briefly describe its connections. Topic 1. Piping and instrumentation diagrams. A piping and instrumentation diagram, or P&ID, represents the piping and process equipment in a system and the instruments that monitor and control conditions in the system.
Here's an example of a P&ID. These symbols represent the instruments in the system and indicate their locations. A circle containing letters is widely used as the symbol that represents an instrument on a P&ID. The letters designate the type of instrument and its function. The meanings of the letters can be found on an instrument identification chart. Since the meanings of the letters can vary from plant to plant, it's a good idea to check an instrument identification chart when you're reading a P&ID for the first time. The meaning of each letter in the left-hand column varies depending on the position of the letter in the symbol. In most cases, the first letter in the symbol designates the process variable associated with the symbol. For example, A as the first letter indicates that the instrument performs an analysis, such as a pH or density measurement. In this symbol, the first letter is L. What do you think it designates? Correct. An L as the first letter means that the instrument measures level. If the first letter doesn't indicate a process variable, its meaning is usually explained on the chart. For example, H as the first letter stands for hand and means that the instrument is operated manually. The second letter in an instrument symbol usually indicates the type of instrument or its function. The second letter in this symbol is an I. So this symbol represents a level indicator. Instruments that are located near a piece of equipment, like the level indicator for this tank, are referred to as local instruments. They're represented by a circle and letters. Remote instruments, which are typically mounted on a panel with other instruments in a control room, are typically identified by a line through the symbol, like the one here. Many instrument symbols contain more than 2 letters. This usually means that the instrument has more than one function. In this case, the third letter, C, means controller. So this is a level indicating controller. In some cases, the third letter is a modifier. For example, according to our identification chart, an L in the third position represents a low value for the process variable. The letters in the symbol stand for level, alarm, low. So this is a low-level alarm. In facilities with many similar control systems, numbers and letters may be added to the symbols to identify separate systems. The symbol identification usually matches the identification of the equipment that the control system is associated with.
Reading a PNID involves identifying and interpreting symbols for instruments and other system equipment. Let's go through an example diagram to see how this is done. As we go through the example, we'll use this instrument identification chart to help us identify and interpret the symbols we find there.
We'll start at acid tank AT1. There is only one instrument symbol shown for the acid tank. The symbol containing the letters LI represents a locally mounted level indicator that shows how much acid there is in the tank. Storage tank ST1 also has a local level indicator. Lines with slashes usually represent pneumatic signal lines, and dashed lines typically represent electrical signal lines. There's a symbol containing the letters FI connected to each of the process lines that are connected to the mixing tank. According to the chart, an F as the first letter means flow, and an I as the second letter means an indicating function. So these symbols represent flow indicators. In this case, the flow indicators are mounted locally in the piping leading to the tank. The tank has a local temperature transmitter that sends an electrical signal to a remote temperature indicating recorder represented by the symbol labeled TIR. It also has a level transmitter labeled LT. The transmitter is connected by pneumatic tubing to a level indicating controller. The controller sends a pneumatic signal to a control valve. The last group of instruments we'll look at is associated with the dilution tank. This symbol, labeled FRC, represents a local flow recording controller that measures and records flow from the mixing tank and adjusts the flow of water from the water system into the dilution tank. These symbols represent the components in a high-level alarm system. The LT represents a level transmitter that is mounted locally. There are also two other symbols. One contains the letters LSH, and the other contains the letters LAH. Referring to our chart, we find that the S as the second letter indicates a switch, and an A as the second letter means an alarm. The H as the third letter signifies a high value for the process variable, in this case, the level of the material in the tank. So the LSH symbol represents a high-level switch, and the symbol containing LAH represents a high-level alarm. There's also a level transmitter connected to a level indicating controller. The controller is connected by pneumatic tubing to an actuator that operates a level control valve. It's called a level control valve because its purpose is to control the level in the dilution tank by regulating flow in the line leaving the tank.
Instruments that are located near a piece of equipment are referred to as blank. Referring to this PNID diagram, what type line is represented by the line running from the acid tank to the mixing tank? In facilities with many similar control systems, numbers and letters may be added to the instrument symbols to the meanings of the letters in an instrument symbol can be found on blank. Topic 2. Using a system diagram. There are generally several kinds of drawings for each system, including a legend. The legend will typically include various types of information.
A legend, like any other diagram, has a title block that gives important information about the drawing. The title block contains the name of the diagram or drawing and its identification number. The numbers are often listed in the diagram book for reference. The title block also contains the diagram revision number. System diagrams are usually revised when changes are made to the equipment in a system. The revision number indicates which version of the diagram you're looking at. The title block may also include additional information about the diagram or the system it represents. Well, now let's take a look at the kinds of information typically found on a legend. For fluid systems, there is usually a section in the legend for valves and related components. It identifies all of the valve symbols used in the diagrams. In addition to valve symbols, this section shows symbols used for valve actuators. A legend also includes a section that shows symbols for major equipment such as pumps, heat exchangers, tanks, and other equipment. The section of the legend that shows instrument symbols generally includes an instrument identification chart. The chart shows letters used on instrument symbols and what the letters mean. Instrumentation symbols are shown in a section similar to this. The instrumentation section of this legend shows how instruments are shown on system diagrams. There's a separate section on this legend for the different kinds of line symbols. This symbol represents the flow path of material through the system, and these represent instrument signals. Abbreviations used on the diagrams are explained in the abbreviations section. For example, the abbreviation NO next to a valve symbol indicates that the valve is normally open during system operation. The last section we'll look at is for miscellaneous symbols. This section contains symbols for components such as strainers and steam traps that do not fit into any of the other categories.
System diagrams can be a big help when you're finding your way around a process system for the first time. As an example of how we can use the information on a system diagram, let's follow along on a diagram as we trace the fuel oil system for an oil-fired boiler. This diagram represents the fuel system for the boiler. The fuel oil is stored in tank number 1. We'll begin here and follow the flow path of the oil from the tank to the boiler.
Oil leaves the tank through this isolation valve. The first component the oil comes to is shown as 2 circles, each of which contains the letter S. It is the symbol for this duplex strainer. The strainer removes solid particles from the fuel oil. From the strainer, the fuel oil flows to a positive displacement pump. There's a pressure relief valve at the pump discharge. The relief valve routes oil back to the suction side of the pump through this line if the pressure on the discharge side of the pump gets too high. This symbol represents a gate valve that can be used to isolate the pump and the tank from the rest of the system. From there, the oil piping goes to the next major components. Two heat exchangers that function as heaters for the oil. Each heater has an isolation valve on its inlet side and its outlet side. These valves allow the oil to be routed through either or both heaters as needed. This symbol represents a pneumatically operated globe valve that regulates the flow of steam from the steam system to the oil heaters. In the line to the boiler, there's an isolation valve and a Y strainer. The strainer traps solid particles that could damage valves and other devices downstream. Next in the line are two isolation valves and a bypass line around a local flow indicator. This arrangement allows flow to bypass the flow indicator if necessary. The symbol for the valve in the bypass line is filled in to indicate that it is normally closed during system operation. Then there is a local temperature indicator. Next is a pressure regulator, which is represented on the diagram by a symbol for a pneumatically actuated flow control valve that is connected to a flow controller. Next is a pressure regulator, which is represented on the diagram by a automatic system that monitors and controls the flow of oil to the boiler. The other valves are for isolating and there is a local temperature indicator if necessary and a local pressure indicator. From there, the oil is fed to the boiler. Components includes a pneumatically actuated flow control valve that is connected to a flow controller. The controller and the control valve make up an automatic system that monitors and controls the flow of oil to the boiler. The other valves are for isolating and bypassing the flow controller if necessary. From there, the oil is fed to the boiler.